Hi everyone, and a big hello to all the pupils from Lowbrook and Holy Trinity. I hope you're all enjoying this glorious weather we're having this weekend. Make sure you do, because next week is looking pretty glum. I'm going to be firing up the barbecue this afternoon, so I'm pretty excited about that. Pretty happy chappy this morning. Can I also say it was so nice to see my 6G class on our Google Hangout on Friday. Well done all for getting on, and well done for your contributions. I thought you were absolutely brilliant. So today we are going to do a little bit of work on volume. So before we go on to that, we've got a little bit of a starter. So yeah, let's get on with it. Okay, so here we go for today then. So before we go into our main, we're going to do a different sort of starter today. So we're going to be using a Venn diagram. So for anyone who's not familiar with a Venn diagram, it looks a little bit like this. Well, it looks exactly like this, in fact. So just to run you through it, any number that's a multiple of 3, a number that's in a 3 times table, will go into this section here. Any even numbers will go into this section here, and any numbers that are both multiples of 3 and even numbers will go in the middle. So a multiple is a number that's in that numbers times table. So let's have a look. Is 9 a multiple of 3? Is it in the 3 times table? Yes, it is. Is it an even number? No. So it will go over here. 14 in the 3 times table? No. Sorry, in the 3 times table? No. Is it an even number? Yes. It will go in here. 27 multiple of 3? Yep. Even number? No. 17. Now that is neither a multiple of 3 or an even number, so that will just stay on the outside here. 24 multiple of 3? Yep. Even number? Yep. So we'll go right in the middle. And 12 multiple of 3? Yep. Even number? Yep. So that will go right in the middle too. Okay, so I probably should have said before the last one, then press pause to have a go on your own, but hopefully you've worked out by now that's what you have to do. So let's have a look at this one. Factors of 54. So factors are numbers that go into another number. So numbers that fit into 54. And cube numbers on the right hand side. So cube numbers are numbers that if you multiply a number by themselves twice, they get to that number. So for example, 4 times 4 times 4 would equal a cube number. So if you're not too sure of your cube numbers, you might want to just jot them down now quickly so you're aware. Let's have a look at the first one then. Number 9. Is it a factor of 54? Yep. Is it a cube number? No, it is not. So it will go in the left-hand side. 27. Is it a factor of 54? Well, hopefully you've worked out that if you double 27, it would make 54. Is it a cube number? Let's think about it. 3 times 3 makes 9. 9 times 3 makes 27. Yes, there's a cube number too, so that will go right in the middle. 12. Is 12 a factor of 54? No, 54 is not in the 12 times table, so I'm going to leave it on the outside there. Is it a cube number? Better just check that first. No, it is not, so that can stay on the outside. 1 is a factor of 54. Yep, 1 fits into all whole numbers, so it will definitely go in there. Is it a cube number? Well, 1 times 1 times 1 makes 1, so yes, it is a cube number, so it'll go right in the middle. Number 6. Is it a factor of 54? Yep, 54 is in the 6 times table. Is it a cube number? No, it is not, so it'll go right over here. And 8. Is 8 a cube number? Yes, it is. 2 times 2 times 2 makes 8. Does it go into 54? No, it does not, so 8 will go over here. Okay, so your next challenge is to work out what the 2 categories are. I've put the numbers in. You've got to work out what the categories are. So off you go. Press pause if you want to crack it on your own. Okay, so I'm going to reveal now that the category on the left is the 7 times table, or the multiples of 7, and on the right is square numbers. So well done if you crack that. Okay, so today we're going to do some work on volume. So the volume is the space inside a shape. So we're going to do some work on the volume of a cuboid or a cube. So your learning intention is, can I multiply the length times the width times the height to find the volume of a cuboid? And can I solve problems involving volume. And of course, there'll be the best in the business bonus questions at the end. Okay, so we're just going to have a look at a cuboid here, first of all. So as I said before, to find the volume, you multiply the length times the width times the height. Some people call it length times depth or some other different terminology. This is what I call it, so whatever you want to call it is absolutely fine. Now, you can actually multiply those in any order and you'll still get the same answer. So let's have a look at the first one for you guys to have a go at on your own. Press pause to work it out. So you should have multiplied 5 times 4 times 3 or whatever order you want to do it in, and you should have worked out the answer is 60. Now we measure volume in cubed, so that's 60 centimeters cubed with a little 3 after the centimeters, and of course if it was meters it'd be 60 meters cubed. Here we go then, first questions for you to crack on your own. Press pause to have a go at them. And here is the answers. Okay, so next lot of questions. Ignore the question numbers at the top. Just press pause, have a go on your own before I go through to the answers. So here are the answers for you to mark your work. And next lot of questions, again, ignore the question numbers at the top. Press pause to crack them on your own. And here's the answers. Okay, so next question. Which box would be most suitable to hold 700 centimeters cubed of cereal? Press pause to have a go on your own. If not, I'm going to go through the answers. So hopefully, if you've gone through and worked them all out, you should notice that box C is 720 centimeters cubed, and that is the most suitable box to hold that amount of cereal because it's closest number to 700. Okay, next question. Press pause to have a go on your own. If you're not too sure, I'll go through it now. So it says the volume of this box is, or this cuboid is 60 meters cubed. Find the missing side. So we know that 2 of the sides are 6 and 2. So if we multiplied 6 by 2, you should know that that makes 12. So we need to work out what you have to multiply 12 by to get to 60. So you should have got to this point here. 6 times 2 times what equals 60, or 6 times 2 is 12. And hopefully you worked out that 12 times 5 is 60. So the missing side is 5 meters. Okay, next question. So press pause to crack this on your own. If not, I'm going to go through to the answers. So here is the answers you should have found. Okay, so here we go then. It's time for your best in the business bonus questions. So press pause now to crack these on your own. Okay, so let's have a look at the first question. How many small boxes can fit into the big box? And it is not drawn to scale. Obviously you can see from looking at it and the different sizes. So you'd have to work out the volume of the small box and the volume of the big box and work out what you have to multiply the volume of the small box by to get to the volume of the big box. And hopefully you should have worked out you need to multiply by 24. So therefore 24 small boxes can fit into one big box. Next question. One face of a cube has an area of 36 centimeters squared. What is its volume? Right, so let's think about this face of a cube that's 36 centimeters squared. What has each side of that face got to be? Well, you should have worked out that 6 times 6 makes 36. So we therefore know that this cube, the length, the width and the height are all 6. So 6 times 6 times 6, or 6 cubed, makes 216 centimeters cubed. Okay, so let's have a look at the next question. What's the volume of this shape? So there's some missing sides you've got to calculate, which is this part here. So hopefully you've worked out that from here to here is 3 centimetres and the whole thing is 8. So this part here has got to be 5. Then you can work out the volume of both of them and add them together. The answer being 200 centimetres cubed. Okay, so I hope everyone got on all right with the maths today. Remember, if you do get questions wrong, it's not the end of the world. That is how we learn. We learn through our mistakes. So don't give yourselves a hard time. Anyway, I'm going to go. I'm going to go and fire up my barbecue and enjoy a nice afternoon in the sun. I hope you all have a great day too. Stay safe, be good for your parents, and I'll catch you next time.